Good morning everyone, I am Mr. Ish. Thank you for joining me this morning for this particular video here. This question here was provided by a certain friend of mine who was telling that in the calculus class the students, 60% of the students failed to get this one right, and he was recommending this for this video. It would be a good presentation to handle and learn how to do this particular differential equation, linear first order, and let's do that in this video. We can also understand why perhaps a large number of students in that class were getting this or failing to get this one right. We have t dv over dt plus 2v is equal to t squared minus t plus 1. When the t value of 1 is inputted into the function, you have a value in terms of v of 1 over 2. Remember, here in places of t you could have had an x, in place of v you could have had a y. But here we're looking at t's and v's, so don't let that variable change over there confuse you. When you're looking over here, you want to try to convert everything into this form, and I'm going to be using x's and y's, but then we'll go back to the t's and the v's. You want to convert everything into this. dy over dx plus py is equal to q. That's what you want to aim for, and you can by eliminating this t. If you were to divide everything here by t, you can arrive at that form, and you'll have dv over dt plus 2 over t v is equal to t minus 1 plus 1 over t. I've divided everything by that t. Now what's the next step? I have it in this form. I want to be looking at my integration factor. You know the integration factor is always e integral p dx, except here my p value is 2 over t. So I'm looking here at 2 over t dt. When I'm doing this, you know what you're getting. You're getting a natural log. You're getting e 2 natural log t, which is e exponent natural log t square, which is really t square by means of properties of logarithms. The integration factor is t square. You'd multiply that across right over here, and you'd end up getting t square dv over dt plus, it'll hit over here, you'll get a 2tv is equal to t cube minus t square plus t. That's where we have arrived, and we're heading here in the correct direction. Sometimes when you're presented questions and you're not seeing the traditional x's and y's and you're seeing different variables, that in itself can be confusing for some students. When you're looking over here, what are your factor for which implicitly derived you'd get this? Look at this and then look at this v and combine them. You're looking here at d over dt, v t square is equal to everything you see over there. T cube minus t square plus t. Now bring in the integral signs with respect to dt. This will cancel out. You'll here have v t square is equal to, now do the antiderivative of this polynomial, which isn't hard. You'll have a t4 over 4 minus t cube over 3 plus t square over 2 plus c. So coming here to this stage has not been extremely difficult, but it's not hard from here. Take the t square onto the other side and things will cancel out. V is equal to t square over 4 minus t over 3 plus 1 over 2 plus c over t square. Now you have to come back and look at this. In places of t's you'll put 1, in places of v you'll put 1 over 2. 1 over 2 is equal to 1 over 4 minus 1 over 3 plus 1 over 2 plus c. Now solve for that c. And it's not hard, just do everything here on the calculator. You have a 0.5 minus 0.25, which is 1 over 4 plus 1 divided by 3 minus 0.5, which is that 1 over 2, and this gives you the value of c, 0.0833. Now if you're unsure what this means, just do the reciprocal function on this and it'll give you an idea. You get a 12. So you're really here looking at a 1 over 12. 1 over 12 is the value of c. All you have to do is come back right over here at this equation and incorporate that 1 over 12. And you can do that. You will have 1 over 12, you'll have 1 over 12 t square, and that'll be your answer. So the answer to this particular differential equation when solved is v is equal to t square over 4 minus t over 3 plus 1 over 2 plus 1 over 12 t square. And this differential equation has been solved for you. And it should be right. The answer over here is good. Perhaps the most difficult part over here is recognizing that you're dealing with something like this once you eliminate the t. And the second most difficult part of all of this would be the fact that you're dealing with t's and v's and not x's and y's, because that can sometimes throw a student off. And lastly, I would say having to deal with something like this makes the question a little more difficult, because you can make a mistake, a silly mistake, incorporating these values and solving for that c. Always remember to replug the value of c once you've determined it into your final answer, because the final answer should no longer have the constant of integration, and that everything should be in terms of the two variables that you see. And that's it for this video. Have a good day.